Hello, everyone. Welcome to the Sitecore Global Virtual Summit, where this week we are diving into the topic of testing and optimization. I'm Michaela Ross-Marin, Field Marketing Manager at Sitecore, and I'll be your moderator for today. Today's webinar is being recorded and will be available on demand shortly after. If you have any questions throughout the presentation, feel free to ask them as we go. Simply type your question in the Ask a Question box located right below the slides. We will not be answering questions at the end of the presentation, but instead will follow up afterwards. Today we have Patrick Peroni joining us. Patrick is a senior consultant at ARC Systems, taking a lead on internal development best practices, guiding the development and management of ARC's Sitecore SDK. With that, Patrick, I'm going to let you take it from here.
Thanks, Michaela. Hi, everybody. So I am a big proponent of DevOps. It's a passion of mine. Sitecore is too. I've not just a senior consultant at ARC Systems, but I'm also a two-time MVP, and a large part of what I've done in the community is write some topics around DevOps. And part of the reason why I'm so passionate about DevOps is because I believe it is a critical path to delivering quality code on time, on budget. Now, I think most people, when they think about DevOps, they think about continuous integration, they think about continuous deployment, perhaps, and, you know, testing is probably an afterthought. It is the veggies of the development world. It's not the funnest topic. Most people don't particularly enjoy it. They view it as drudge work or a duty, not as something that's maybe of value. Now, I think most people would recognize that it's something you should do, but maybe it's useful just to talk about what is the value of testing, the good part. It obviously, I think, helps us to deliver working functionality, right? We all have experienced yellow screens of death, hopefully in our local environment, not a higher environment, and when we're testing ad hoc ourselves. So if we have some sort of unified approach to testing, then we can try to catch those breaks in our code in a lower environment regularly before they propagate to higher environments. Another, I think, really important point that testing helps us with is it helps us to make sure we're meeting or exceeding business requirements. You may not get a yellow screen of death, but you might have a slightly more subtle error in the code you deliver. Perhaps it's a particular part of the rendering that doesn't quite show the way it should for a particular edge case. You know, if we were to test that, maybe we'd catch it. I think another important good point of testing is it helps lower the friction of refactoring code. I'm sure many of you have been in the situation where maybe you inherited some code, or you were into a project and there came a certain point where you realized there was some code you needed to refactor, and of course there's always that fear in the back of the mind, if I change this, what am I breaking, or what subtle thing am I not thinking about? The nice thing is if you have some tests built up, you can help reduce the chance of breaking something through refactoring. So that's the good. What about the bad? Well, as I kind of alluded to, oftentimes tests are manual. It's very often it just means you deploy some code locally and you go experiment with it. They're tedious. Maybe they're complicated. You know, it's several steps of actions before you get a test result. And I think we can all relate to waiting for Sitecore to spin up that first time after deploying code, and that makes, you know, yet another point of tedium that you have to contend with. Since tests are often ad hoc, that means they're probably not documented. And if they are documented, maybe they're not documented completely. So they could be incomplete. It's often disconnected from the work of the developer. What do I mean by that? You're probably developing your code, checking it into source control, but are you, the developer, thinking about systematizing that test? How are you communicating that test to hopefully someone other than yourself to run? That's through an email, preferably not, but perhaps. Is it through something like Confluence where you're documenting that in a rigorous way? Perhaps, but again, maybe not. It would be nice, though, if the documentation served as, in a sense, the code of a test. Perhaps better than writing a set of manual steps, we could mitigate that through some sort of automation. So now, what about the ugly? Well, as a result of sort of the impediments, the bad, we get the ugly, which is tests are usually ignored, or they're delayed, meaning they're put off to the end of the project rather as an afterthought. Or again, as I was mentioned, they're incomplete. There's not enough time to go through all the code that's been written to try and document every single test edge case that you probably should. And sometimes there might even be an argument that some tests don't need to be a part of your system of tests. But how do you arrive at that decision? Do you arrive at that decision 2 months into the project when you're sort of facing the go live approach date, or is that wrapped up into your development process? All right, so now that I've sort of talked about the good, the bad, and the ugly of testing, let's just talk about how we normally deliver code, and that way I can kind of couch my approach to testing in a larger framework. I did mention DevOps, and I believe testing is a part of DevOps. So let's just take a step back and think about how developers deliver code. And I've got this pyramid model that I think helps us think through that. I think most developers are very familiar with the very apex of that pyramid, authoring code. I think most of us probably don't think about if I can switch metaphors on you, the iceberg underneath that tip. They're living in Visual Studio. They're thinking about how to write something in C# or CSHTML or what have you. They're not really thinking about the underlying layers. But the underlying layers are a part of how we deliver code, and they have an important story that must be told. A lot of developers are probably somewhat familiar with the build code. Certainly they're familiar with building locally, right? You just tell Visual Studio, Control-Shift-V or whatever, and off you go. Your code's compiled. Maybe even set it up to deliver that code locally to your local sandbox. That would be good. At least you automate that. But that's probably the extent most developers go to and thinking about how to deliver code. When it comes to higher environments, we need to think about that process a little bit more in depth. You've got a shared dev environment, most likely, perhaps a QA environment, hopefully, and of course a prod environment. And you have to think about how you're going to get your code from your local environment through source control, perhaps, all the way up through those higher environments. So we got to think about how code gets deployed. We got to think about deploying third-party modules, because there's oftentimes a very good chance you have code that depends on some third-party module, right? So it's not just deploying your own code, it's deploying those modules and making sure that you got the correct version. It's delivered before you deploy your code, so you don't get into a weird situation where you're having yellow screen of death because you got a missing dependency. And honestly, before we can even think about deploying code, we need to have Sitecore installed. So that's the platform software, Mongo, Solr. If you use Solr, probably you should. You got to have all those things in place and installed. And to do that, you need to have your servers provisioned as well. So there's a lot of layers to this pyramid that have to be thought about. And maybe not every developer, if they're on a project where someone has given thought to how to set up all these separate tiers, maybe not every developer has to be constantly cognizant of that fact. But if it's on you to deliver the solution and you have to architect that, then certainly you need to be aware of it. And even if you aren't that person in that role, it's probably useful to at least be aware of how these layers interact with each other. So if you ever do have a problem, you have some notion of where to start to fix it. So now that we've sort of discussed the layers, let's think about how it is we actually manage them. When we're talking about authoring code and building code, what we're really talking about is we are managing packages. If you're on the marketplace, we're all familiar with .zip modules that Sitecore provides. That's a type of a package. If you use Hedgehog Team Developer Sitecore, TDS, then you're probably familiar with update packages, because that's the package type that it's easy to automate the creation of with TDS. And it's the one I tend to use most, but there's other ways of generating packages. You could use Unicorn, a combination of Unicorn and just normal class libraries, web projects in Visual Studio, along with perhaps Gulp tasks or automation scripts to manage generating your packages for you. Now, when I talk about packages, I've kind of mentioned modules that Sitecore uses to install, be it a .zip or a .update. But there's also the notion of packaging that module inside of a release. And that's what the second layer is about, because every build, you're generating most likely a slightly different version of that module or modules that your solution creates. So those are releases. And you need to be able to manage how you are deploying those releases. And that's what that second tier is indicating. And then finally, the third tier is how you're managing your servers. There's different tool sets for that. It could even be that it's 100% manual. Someone went out, perhaps in an on-prem environment, manually spun up those servers, manually installed the software. I think technically we can consider that a way of managing servers. I think we could all agree that if you can bring some automation tools to bear, then you're better off for it. So let's just take a quick swing at what different tool sets that we often use, I often use for Sitecore, and where they kind of plug into this logical architecture. So at the apex, right, Visual Studio, Git, or perhaps Team Foundation version control, or it could be some other source control not listed. It could be SVN, it could be something else. The point is you're definitely using Visual Studio paired with source control. For building code, we're thinking about a continuous integration platform. It might be TFS. It could be TeamCity. It could be Jenkins. It's some system that invokes MS Build. So there's a lot of flavors of that. I've listed a few that I'm familiar with. At the manage release tier, and in between, right, we got to connect these tiers. So I tend to use NuGet feeds to connect my managed packages to manage releases. And what I'm really saying there is when my build server creates an update package, because that's the type of module style that I tend to prefer with Sitecore, I actually embed that update package or packages inside of a NuGet package. So it's, it's like Russian dolls here. We have packages within packages. And I do that because by embedding in a NuGet package, I get a version. I can version control my NuGet package, which corresponds to releases. And that's handy for Octopus deploy. Now, there are other release management systems out there. TFS has release management. There's others beyond that. I've only listed Octopus Deploy because that's the one I'm most familiar with, but I don't mean to say that it's the only valid answer. And I use Octopus Deploy for both deploying my code, and I also use it for deploying third-party modules. And then finally, I also have next deploying code to the managed servers part of this. Think of Octopus recipes or tasks, right? That's the process that plugs into the managed server side via Tentacle, so it's an agent that sits on the server that deals with installing the dirty work of installing the release on the targeted server. So that's what Octopus tasks are for. It's just an agent following a recipe from Octopus. Hey, when this release is being deployed to server X, you need to unzip the NuGet package, pull the update package out, apply it to the server, give me some indication of success, move on. Finally, at the managed servers layer, just to sort of fill out this picture, one example of how you might manage installing platform software, that is Sitecore itself, is DSC. DSC is an extension of PowerShell, so think PowerShell scripting to install Sitecore and or other subsystems like Mongo or Solar. Finally, for provisioning servers, you know, it really depends on your environment. If you're in Azure or AWS, then you can leverage templates for stamping out servers. Okay, so I've kind of been going on here for a while about things not related to testing, so maybe you in the audience are asking yourself, well, what about testing? And I'm glad you asked. How does testing fit into this picture? Well, it fits in at various places, and I'm not suggesting that this is the complete picture of all the different insertion points for tests and test types, but I think it's a useful guide to think about. You know, at the apex of the pyramid, we have compile time tests, right? If you have a blown reference, your compiler is going to yell at you. If you're missing, it's got a syntax error, again, compilers will yell at you. Unit tests, I hope we all know what unit tests are. That's sort of the next step in the food chain. Those unit tests can be run while you're authoring code. Maybe you are manually executing a test runner, or maybe you have something like nCrunch that's just automating that for you. Certainly, when you're building code within your CI platform, again, the compiler's running. You know, I certainly hope you're leveraging unit tests at that time too. And it's also the first point where perhaps you're leveraging functional tests. You could be leveraging arguably functional tests maybe during the authoring code part, but really what I mean by this is, and let me just break away, it's probably a good point to define what I mean by a functional test for purposes of this lecture. A functional test is different from a unit test in that a unit test is testing a small part, perhaps a method in your code. And a functional test is more about testing the output of a web server. You're making a request to the web server to test. This is how I'm talking about functional tests. I'm not suggesting this is the end-all definition of functional tests, but the sense that I'm using functional tests in this lecture, that's what I mean. I'm making a request to the web server to pull back some HTML because I want to see HTML. So let's think about a controller rendering, right? In a controller rendering, you've got some controller logic, you've got a model, perhaps, most likely, and your unit tests very likely are testing the code in your controller, and they're probably also testing your model. What they're not doing is testing the view, right? That you're not really doing that in a unit test, but your functional test could be, and perhaps should be. Continuing on with some other places and other types of tests, again, we could be running and should be running functional tests when we're deploying code. So when I'm talking about functional tests here at build code, think about like locally running a functional test. Whereas in the manage release tier, when I'm talking about running a functional test at the deploy code tier, think about running a functional test against your shared dev environment, a QA environment, some higher environment. And it's also a point where you could start adding in a lot of other types of tests, UAT, performance, smoke tests. Those are all sorts of tests that you might wire into your deployment framework. Finally, at the lowest tier, an example of a kind of test you might be running there is compliance tests. You install the Sitecore platform. Oftentimes, clients might want you to perform a penetration test. So that's what I mean by compliance test. So that's a sort of overall view of the testing stack. Let's think about the importance of the feedback loop with testing, because all these sorts of tests, they have a cost associated with them. They take some time to set up and manage. And what's the payoff? Well, the payoff is the feedback you receive from a test. I mean, we all understand the feedback we get from a compiler, and we all understand the value of that. You can't run code that doesn't compile. And it's also the best example of a super fast feedback loop. You build your project, and it either compiles or it doesn't. And if it doesn't compile, you know right then and there. You don't have to watch and wait for someone to go manually deploy your change or some process to deploy it. Go inspect that yourself somehow. The compiler tells you right then, right there. Unfortunately, and too often, we have other tests beyond compile tests that are further out in the feedback loop than they should be. So what do I mean by that? I'm going to back up a slide here. Let's think about UAT tests, or let's think about maybe functional tests. If we're not performing them in our local environment, or if we're not performing functional tests in a shared dev environment, where are we doing those? Maybe in QA, hopefully not in prod, but I think I've seen that happen. And what does that mean? Well, it means that you're waiting an extended period of time to receive feedback that change you made to the model or the HTML change you made isn't giving the results that quite line up with what the client expects. And if we can short circuit that feedback loop, if we can shorten the time it takes for you to author a change, check it in, and build it, deploy it, then that means it's the faster you can turn around feedback from that change. Hey, the sooner I know there's a problem, the sooner I can fix it. And that's what unit testing, that technique was really developed, was to help solve. And it does a very good job of that, providing you actually invest the time to create unit tests. You greatly shorten the turnaround time of authoring a change in code and realizing that maybe you didn't catch an edge case. So the question is, can we do something similar for functional tests? And again, what I mean by a functional test, I mean being able to understand if the output HTML from a let's say a rendering matches what their requirements are. I sort of like to think of a functional test as being a rough analog to unit tests, right? I've got unit tests, again, for my model, controller logic. It'd be really nice to have a functional test that's roughly an analog for the view side of that. So what can we do to ease the creation, maintenance, and automation of tests? Well, it's demo time. So I'm going to switch to a demo, and I'm going to show you some tooling around that. Okay. should be sharing my screen at this point. Out on the marketplace and out on GitHub as well, I created a module called Layout Simulator. And the basic idea of the Layout Simulator module is you get a service endpoint that you can make requests to, telling the service endpoint, here's the layout and the rendering I want you to draw for me, and that endpoint will spit back to you, return back to you the HTML of that layout and rendering, or even multiple renderings. That way you don't have to build up a huge library of static test pages in Sitecore. So that's the rough idea of Layout Simulator. Let's just really quick. This is an example of Habitat that I've deployed Layout Simulator to. This is a very fresh install of Habitat. We're working off of Sitecore 8.2 Update 4, and I have installed Layout Simulator, so I get a couple of pages here. Oops, refresh. So I get a couple of pages here that Layout Simulator provides me with. We'll explain what these are here in a moment. I also get, in my ribbon, a Layout Simulator button. It's sort of a helpful tool. What does this do? Well, I can just go to some example page, and I can pull back all the layout information for that page. So let's just quickly take a look at what Habitat, the homepage, looks like out of the box before I hit go on our Layout Simulator. All right, so this is what the homepage looks like when you actually visit the real thing. I got the layout definition. So this is the Sitecore layout definition of that homepage. That's what all this crazy XML is. If I hit Simulate Layout, I'm going to go visit this simulation host page. This is my host page. I can move it around in the tree. If I do that, I need to be sure to set a setting in Sitecore that we can look at here in a minute to tell my service endpoint where my host page lives. And this host page will then draw my simulated page. So let's hit the button. There's a quick interstitial while this is loading, and we get our simulated page. What is that? Just to prove a point, what does the host page actually look like if I just visit it manually? So there's nothing there. It's just an empty layout with this kind of warning message rendering. So we're definitely simulating the home page. There's no magic involved here. What's the usefulness of having this get layout? Oops, I got the layout for, yeah. So this is the layout for this host page. Again, just a layout and a rendering. Let's flip back to the home page itself, get the layout again. This probably will look intimidating to non-developers. Hopefully, you have a team, if you are a developer, in which you could help your testers navigate this structure. Oftentimes, I think of being an agile work environment where you're working on a particular rendering, and to me, as part of the course of doing that work, forget Layout Simulator or a testing framework. Almost for sure, you've built up a test page yourself, and you've added that rendering to a test page. So you could just go to that test page, I'm talking about in your local environment, get the layout from that test page, and just provide that XML to a tester and say, here, here's how you can dynamically generate the rendering HTML. All you need is this XML. And what I mean by all do you need is this XML? Because we haven't seen the endpoint itself yet. We haven't seen the service yet. How does that work? Well, I've got Postman running here, and this is what the endpoints themselves look like. So if I send this, I just get a quick indication that Layout Simulator is up and working. And then here's how you simulate layouts through the service. Let's look at the format of this. We're sending JSON, and I've encoded in JSON our layout to simulate. So in other words, you just need to take the layout from here, and you can manipulate this layout, which I'll show you here in a minute. Cut paste it into your, if you were using Postman, you just cut paste it here in Postman and send it, right? And in response, you would get the HTML. Let's actually try that. So I've simulated the home page. Let's try, I'm going to take this. The only reason I'm not cut and pasting from Postman is because Postman, I have to escape all my quotation marks, so there's just convenience here. Oops. Right. So in a browser, this is what you see. In Postman, this is the HTML. And great. So if you have a tester now that you've provided, or they know how to find for themselves the layout definition, then they can start through scripting making requests to the service endpoint for Layout Simulator and receiving HTML that represents that simulated page, that simulated rendering. And then they can inspect that HTML and make some sort of decision through script if it's correct or not. Let's take a look at how that might work. So in the Habitat solution, which I've slightly modified here, and we'll talk about how you can modify it similarly for if you want to play around. I've added a new gulp task. Yeah. Here's my new gulp task. So what am I doing here? Well, I'm invoking a PowerShell script called functional-test ps1, which I added to the root of my repo, and we'll look at that here in a minute as well. And I just run that test. And that test then examines the rendering and responds with either a success or a failure. If we want to see what that looks like, I can just go in here and run it. We had a successful test there. We exited with a code of 0. So this is good. We're currently in compliance with our test. What does the PowerShell look like? Not very complicated. I've got a helper function up here at the top, invoke functional test. I'm not going to go into great detail about that. I'm providing a gist of this, so if you want to examine the inner workings of that yourself, you will have access to do so. I think what's more important is, clear this noise off. What's more important is what's going on inside this test rendering function, which is what gets run when we invoke the script. Well, here's our test data. So we're supplying a layout to simulate, and then a modified layout definition. And we simply invoke our helper function to use that test data. And we do some very simple examination of the results. What am I doing right here? Well, I'm looking at the parsed HTML. there's an anchor tag inside of this, and I'm examining the target attribute for the anchor tag, and if it's not underscore blank, then this is a rather contrived test, right? I want simplicity. If it's not underscore blank of the value of the target, then we're going to throw an error. How did I get to here? I'll just quickly talk about that. Let's go back and look at our layout. There's a lot of layout definition here. I copied and pasted this in a text file, and I just started stripping out renderings until I got to the critical 3 renderings that I needed for this call to action. What call to action are you talking about, Patrick? Well, let's look. Here on the home page, we have this rendering right here, which is a call to action. So I decided to simulate being the developer and user story, and I'm developing this call to action. And maybe in my test, I'm concerned about, let's just inspect this element. I'm concerned if the target is underscore blank. That is what my functional test is validating. Now, if you look at the Habitat code, there's no explicit code that enforces, meaning Habitat custom code, that enforces this target underscore blank. What's really doing that is, what's really doing that is this definition item here, this data source item. We'll come back to data sources here in a second because I think it's an important point as well. So this is a data source item for this particular instance of the call to action rendering. And I'm currently looking at raw values. So here my raw value is target underscore blank. Let's just see what happens if I change that. And in your head, imagine instead of this being the output HTML being dependent upon this field value, imagine instead it was based upon some bit of code that you authored, right? So what we might do is we'd author that code, we'd build that code, and since we're in Habitat, we have this default task which would invoke all of these subtasks, including this run functional test. I'm not going to do that because it takes a while. So I'm just going to now manually invoke run functional test and see what happens. Okay, we just got an error. So this is the feedback loop. This is exactly what I'm talking about. If you have a library of automated functional tests built up over time, then you can start to receive some feedback even inside your local dev environment about whether or not you broke a view rendering without having to go manually create a test page, load that page, look at it, maybe look at the HTML, decide if it did what it needed to do. Now, about a minute ago, I said something about we'll come back to data sources because I think that's important. Let's go ahead and discuss that as well. One of the nice things about having access to these layout definitions are you can swap out data sources. So if there's another data source, there's no reason at all why you couldn't have your QA team who's maintaining these scripts. They might have like several data sources and they just run through a particular rendering, trying out each of the different data source types. This call to action is actually a good example of that. I think there's 4 or 5 different data source types that it can kind of consume. I'm using types loosely here. The download data source we're looking at has an HTML link. Let's see what happens when we use this data source here, which is not there's no button on this particular data source. So let's just take this full bit of layout definition. Let's throw that into here and simulate what that looks like. So it's the same rendering, different data source, therefore looks different. And you can start to get into edge case testing, right? Your data source works with your rendering works with a particular data source you, the dev, are familiar with using. But hey, did you go through all the different permutations of data sources where some fields might have been blank? You know, did you defensively code against that? I don't know. What if your data source accepts what if your rendering can work with multiple data template types and the range of fields differs? Did you defensively code around that? I don't know. But if you have a set of functional tests built up, they can help catch some of that, and they can certainly help catch flaws or deficiencies in your HTML itself, which is not something a unit test is well adapted to catching, right? We want to invoke the web server to generate the HTML so we can inspect the HTML and make sure it meets our idea of compliance. And that's what these functional tests allow you to do. Another thing I want to touch on here is this demo has shown you how I've integrated functional tests inside of Gulp, which ships with Habitat. So I thought it was a useful starting point because a lot of you are going to hopefully be familiar with Habitat, sort of familiar with some of the ideas in it, and it ships with this, it ships with a Gulp file that sort of has a stripped down version, let's say, of CI and CD. You invoke your default task, and you're invoking not only a build but a deployment, and it's not a hard stretch, I think, to generalize from here how you might take. We've seen how we fit functional tests inside, extended their CI/CD pipeline, if you will, to include functional tests. If you're using a more, I guess I want to say robust CI/CD set of tool chain, like we discussed earlier, maybe it's Team City and Octopus Deploy. How do you fit functional tests into that? Well, that's kind of up to you. I can envision several different ways of doing it. I think the main takeaway for you is, as long as you have Layout Simulator in place, you have that service endpoint that you can invoke from any scripting language you want. I happen to use PowerShell here because it's convenient and I like PowerShell, but it could be Python, it could be whatever. And you're just making multiple invocations, web requests to that service endpoint. And then, of course, you're examining through scripting the output HTML and making some sort of decision upon it. You might even think about tying into Phantom.js. Phantom.js ships out of the box with Sitecore, and it's a headless browser. So if you're worried about more complicated functional tests, maybe where you're interacting with multiple renderings on the same page, perhaps, Layout Simulator can certainly draw multiple renderings on the same page. But if you click a button in rendering 1 that's supposed to cause some sort of reaction in rendering 2, or maybe even further button clicks in rendering 2, how do you automate that? Well, that's where something like headless browsing can help you. And Phantom.js is one possible solution. Another that I've used in the past is Selenium. Of course, Selenium costs money, and you may or may not have access to it. So think about Phantom.js. If you do decide to pursue Phantom.js, be aware that there's scripting tools out there that help extend Phantom.js so that it's easier to script against. An example of that is Casper.js. It's just a library of functions that you can call that make invoking web requests against Phantom.js easier. So it's a convenience. Beyond that, where do you fit the functional tests themselves? Okay, so you've got a library of functional tests in some scripting language, perhaps using headless browsing, perhaps not. Where do you plug that into your tool chain? Like I was saying earlier, that's up to you. One possible place of, and I've done this before, is we've created build configurations in TeamCity, for example. So there might be some build configurations in TeamCity that manage compiling and interacting with Octopus Deploy to deploy to your server. And then after that, some later build configurations then execute test scripts, right? And so all within one nice interface in TeamCity, you get some indication of where you are, successful or not for a particular release, and committing to deploying to testing. Another possible answer is in your release management system, in TFS or in Octopus. Maybe it's in there that you call in your scripting hooks. Hey, you know, in Octopus, after I deploy the set of update packages to my server, now run these functional tests. And if they fail, you know, example on screen here, if we throw an exception, then the deployment failed. And that will then bubble up to Octopus Deploy's admin screen, and you can make some sort of decision upon what to do to correct. All right, so that's kind of really wrapping up the high points of the demo. So some next steps, right? Let's maybe you're intrigued by what you've seen, you see some value there. What do you do next? Well, this slide deck has a couple of links to GitHub for the layout simulator solution itself, that repo, and as well a gist I put up that's got, it's got two things in it. It's got the PowerShell script and a gulp task that you just need to like add to your gulp file if you were to try to do an extension of Habitat like you saw me do. If you don't intend to use any of the gist, you don't have to. You can certainly wire up your own method of scripting into Layout Simulator. I think really the critical component is Layout Simulator itself. One note on that, I did just as part of my preparation for this presentation, I did deploy Layout Simulator to Sitecore 8.2 Update 4, and previous to that, I'd been using it as 8.1. So there's a few changes I had to make to the source code to enable Layout Simulator to work. Long and short of it is I haven't pushed those changes back to GitHub yet. I'll be doing that in the next few days, probably over the weekend, where I can make sure that Layout Simulator works for 8.0, 8.1, in addition to 8.2. Currently, what's up on GitHub, I've only used for 8.1, and I presume it also works for 8.0. It should. So look for that change in the next couple of days, making Layout Simulator function for all versions of Sitecore 8. And with that, I think really the demonstration and the presentation is over, and I'm just going to pass the baton back to you, Michaela.
Awesome. Thank you so much, Patrick. The presentation was amazing, and thank you everyone who attended the webinar today. Again, we are not going to be answering questions at this time. However, if you do have a question, feel free to enter it in the Ask a Question box, and we'll respond shortly after. We will be sending out an email to everyone shortly with access to the recording so you can watch the presentation again or share it with coworkers or friends. We hope to see you at the next Sitecore Global Virtual Summit webinar. Take care, everyone.